Dear viewers, you are my greatest inspiration. You have supported me all these years. Your kind words of appreciation motivate me to keep making more videos. X-ray is a form of electromagnetic radiation of high energy and very short wavelength, which is able to pass through most materials that are opaque to light, for example, human body, hence widely applied in medical imaging. Well, now we talk about X-ray scattering, X-ray diffraction, X-ray crystallography, all sorts of terms. Let's start with a couple of simple definitions. All right. A diffraction pattern is obtained by measuring the intensity of the scattered waves as a function of scattering angle. Peaks intensify as the number of rows increases, in a very similar manner to the diffraction peaks from a diffraction grating as the number of slits increases. As you have already learned from my earlier elaborate video lecture, diffraction refers to the scattering of waves around obstacles or apertures, or the spreading out of wave fronts from a chromatographic grating, which results in diffraction pattern. This is what one can discern in the context of Bragg's law. Please note that X-ray diffraction is often considered a subset of X-ray scattering, where the scattering is elastic and the scattering object is crystalline. In order to discern X-ray scattering and X-ray diffraction, one has to relate to the concept of light scattering. Well, light scattering is defined as a phenomenon of deflection or deviation of light beams from its original course of trajectory caused by irregularities in the propagation, as a result of collision with medium particles and interactions with inhomogeneities in a medium. This phenomenon is responsible for various natural effects, such as the blue sky, white clouds. A typical example is Rayleigh scattering. X-ray diffraction is a phenomenon in which an interference pattern of the waves in X-ray beams occurs owing to the uniform spacing of atoms in crystals. The atomic planes of the crystal act in exactly the same manner as the interaction between a diffraction grating and a beam of light. The specular reflection of X-rays. This is the original historic publication of Lawrence Bragg in Nature back in 1912, still available online for ardent readers. The culmination of structural studies in the history of experimental physics was the historic breakthrough by Watson-Crick double-helix DNA structure housed in the Cavendish Laboratory when Lawrence Bragg was the director of the Cavendish Laboratory, Cambridge. Biotechnology, crime detection, forensic science, recombinant DNA. None of these would be possible if Watson and Crick had not discovered DNA structure using X-ray diffraction. X-ray scattering. An X-ray source sends incident X-rays to the sample at a certain incident angle. A proportion of the incident X-rays are scattered from the sample at a similar or different angle to the X-ray detector. Yeah. If we magnify to visualize what's actually going on inside the crystal sample. Crystals are composed of three-dimensional patterns. These patterns consist of atoms, or groups of atoms, in ordered and symmetrical arrangements, which are repeated at regular intervals, keeping the same orientation with respect to one another. X-ray crystallography involves X-ray diffraction by crystalline solids. And Bragg's method assumes specular reflection from periodically repetitive lattice planes as a prerequisite. So, it would certainly be quite relevant to take a look at a comparative overview for the purpose of conceptual clarification.
Please remember to like, subscribe, share.